1. Dark matter. Galaxies spin too fast. According to everything we know, they should tear themselves apart. They don't. Something invisible holds them together. We can measure its gravity, map its influence, calculate its mass, but we cannot see it. It doesn't emit light. It doesn't absorb light. It exists only through absence. 2. Dark energy. The universe is expanding. That was strange enough, but it's accelerating. Something is pushing space itself apart, not from a center, from everywhere. We can measure its effect precisely. We have no idea what it is. 3. The Great Attractor. Entire galaxy clusters are drifting towards something massive, a gravitational pull beyond visible matter. The source lies behind dense cosmic dust, hidden from direct observation. We know it's there. We feel its pull. We just can't see it. 4. Fast radio bursts. Millisecond-long explosions of radio energy, more powerful than entire galaxies, briefly. They appear randomly. Some repeat, some never do. We can measure their intensity, distance, and frequency, but their origin remains uncertain. Too violent for stars, too brief for known processes. They arrive and vanish. 5. The cosmic microwave background anomalies. The afterglow of the Big Bang should be uniform, mostly smooth, but it isn't. There are cold spots, asymmetries, regions that statistically shouldn't exist. We can measure them precisely. We can't explain why they're there. 6. The Hubble tension. Two methods of measuring the universe's expansion give different answers, both extremely precise, both incompatible. Something fundamental is missing, not an error, a gap in understanding. 7. Matter-antimatter imbalance. The universe should contain equal amounts of both. Instead, almost everything is matter. Antimatter vanished. We can measure the imbalance. We cannot explain how matter won. Without that imbalance, nothing would exist, including us. 8. Cosmic rays beyond known limits. Particles slam into Earth with energies far exceeding what physics predicts possible. No known cosmic accelerator can produce them, yet they arrive, measured, logged, ignored by explanation. 9. The axis of evil. A strangely aligned pattern in the universe's background radiation. Large-scale directionality where randomness should reign. The name is joking. The implication is not. The universe appears oriented. 10. Quantum vacuum energy. Empty space is not empty. It fluctuates. Energy appears and disappears constantly. We can measure it, but when calculations are compared to reality, they're off by an enormous factor, one of the worst mismatches in physics. 11. The missing baryons. Half the universe's normal matter was missing for decades. Not dark matter, ordinary matter. Eventually, traces were found in faint, hot filaments between galaxies. We can measure them now, but we don't fully understand their structure or behavior. 12. Entropy's direction. Time moves forward. Entropy increases. But physics equations mostly work backward too. Why does time have a direction at all? We can measure entropy precisely. We cannot explain why the universe started in such an ordered state. 13. The size problem. The universe appears incredibly flat, balanced with near-perfect precision. Slightly different, and it wouldn't exist. We can measure this flatness. We can't explain why it's so finely tuned. 14. The cosmic neutrino background. Ghost particles pass through your body by the trillions every second. We detect them, barely. They interact almost with nothing. We know they're everywhere, We don't know what role they truly play.